Hello, today I'll be going over the WJC Stereoisomerism Unit 4.1 for organic chemistry. Now this is specific to our exam board, and I'll be going over the generals of what to expect from this topic. So two just normal definitions to remember are the differences. So you've got the same, this is for your stereoisomerism. That's really messy. You've got the same molecular formula with your same structural formula with your different spatial arrangement of atoms. We'll come on to this and why this is and how it all works out in a bit when I do some diagrams. But this isn't to be confused with your normal structural isomerism, which is where you've got the same molecular formula and different structural formula. Okay, so to start off, we're going to do a little recap as well for EZ isomerism. Now, EZ stands for Entgegenzusammen, which is German, and the way to remember it is E for epicet, not opposite. And Z for same or same, referring to the planes. Okay, so a diagram to show this. So here I'm going to draw a molecule of, I'll name it in a minute, your base, which is ethene. So for EZ, you always have to have this double bond between carbons, and it has to have different groups on each carbon for it to be EZ. And you'll see why in a minute. So I'm going to draw this molecule. F. Okay, so this is chlorine, hydrogen, bromine, and fluorine. Now this molecule shows EZ isomerism, and this is due to the priority groups. So fluorine has a MR of 19, bromine has one of 79.9, and chlorine has one of 35.5. Hydrogen you don't really take into account, but it's 1.01 for reference. Okay, so this in effect would be a Z isomer, and that is because you've got your two highest groups which take priority, and they are in your E format. They are an opposite each other. So this is going to be called E, 1 bromo, 1 fluoro, and 2 chloroethene. Oh, it's a really long name. Now its neighbour, which would be our Z isomer, would instead have, if I want to draw this, we'll move to bromine. So we all move, if the bromine becomes up here and the fluorine moves on there, we've now got, instead of it being opposite, it's on the same. So this is going to be a Z isomer. So this is going to be Z, 1 bromo, 1 fluoro, 2 chloroethene. And you can do this with a lot of molecules. So you could have 1,2-dichloroethene would be another example of, so that would be, look something like this. That would be our Z isomer, because they're in the same. So you can have loads of molecules like that. And that's just up to the examiner's questions. Okay, so to move on from our little AS recap, we're now going to look at why a stereoisomer is what it is. So, the basic, general structure you can draw for it is with your carbon as your center, and you do A, B, C. This is your dashed and wed kind of structure. Now this carbon here is actually chiral in nature. Now chiral means where you've got 4 different groups attached to that central carbon. So as you can see, A, B, C, D, these represent different elements. So this, in fact, would be your chiral carbon. Now, these can flip. So chiral carbons, when like this, they're called an enantiomer. And these are what you call non-superimposable. So if I was to get another molecule of that and put it on top of each other, because they would display in mirror images of each other, they would not be imposable upon one another. So meaning I can't put them on top of each other and then be in the same way, because they've kind of shown this mirror display of it. So this would be your enantiomer. Now when you have something called a racemic mixture, this is when you have a 50-50 mix of both of these enantiomers. And to test for these, you can put it through something called plane polarized light. Now this plane polarized light on a normal enantiomer, not in its racemic or racemic mixture, will bend light in opposite directions to what it goes in. So if I draw something like that, this is light going in, it'll come out like that way. But in a racemic mixture, you get both of them bending in opposite directions. So in hindsight, it's just going straight. So you'll have no effect on plane polarized light in a racemic mixture. Now it's a small topic, so I believe that is the end of a general overview of WJC Stereoisomerism Unit 4.1. Of course, you can go on to loads of different more aspects. So you can even have, it might give you molecules where you've got maybe more than one chiral carbon. And then this will be your, it can vary loads. I could go on. I will go on to some questions in the next video.